Hello guys, welcome back to Maison African Motives. Still working on mathematics and that is working on our revisions. We have got the revisions that we are going to work on from our July, that is August 2023 exams, so that we can see how we're supposed to attempt these typical questions. So without wasting much of your time, we shall quickly rush through the questions. Remembering that you're supposed to have your instructions. So this paper was just scanned somehow, but let's just hope it is going to be clear throughout. All right. So this part, I think it's a little bit better. All right, question number one, without wasting time, like I was saying, we are given to solve for P and R in the following simultaneous equations. We've got these two simultaneous equations whereby we are supposed to solve for the value of P and the value of Q in this case. All right, so it's going to depend with the method that you are going to use. Remember, I always say the method that you're going to use depends. All right, so in this case, just going to try to, by all means, to use other methods that we never worked with before, because we have been talking about substitution in many classes that we had. So in this case, I'm just going to avoid my the substitution part. All right, so we are given the equations in this case, minus 12r plus 8p, which is equal to 32 in this case. And we are given 2r plus 3p, which is equal to minus 14. Those were the two equations that we're given. Depending with how we are going to solve your equations, like I always say, here we've got our first equation and we've got our second equation in this case. So I'm just going to try to use elimination method to eliminate either R here or P, then I substitute the value, because I've been talking about substitution a lot of time, but you can use other methods to prove if the answers are the same. So from your elimination method, what you need is to make sure that these two terms, they have the same coefficient, in this case, in terms of the number. So what you simply do is to interchange these two numbers. We're supposed to interchange like this, to multiply on top by 2, to multiply below by 12. This is what we're supposed to do. But these two numbers can be reduced, these two numbers. So what you can do is that when you are multiplying with these two numbers, try to reduce them if they can be reduced. All right. What am I trying to say? We can have this on our calculator. Once you choose these two numbers, you have them on your calculator, which is going to be, in this case, 2 over minus 12. So that's 2 over minus 12, like this, which is going to give us minus 1 over 6. So meaning to say, on top, you are multiplying by -1. Down, you are multiplying by what? By 6, of which the sign in this case is not important, because here the negative is what? On 12 here. So the sign, you cannot consider it. So this is what you're going to do. Instead of multiplying by these big values, we can choose to decide here not to use these numbers, but to use what? To use 1 on top, and to use -6 in this case. All right. So the sign, like I was saying, the sign is not important. So we're just going to write this as a 6. Yes, you can write as a negative so that they'll be directly the same. Then you just have to subtract your numbers, which is sometimes good to do that. But for the sake of all of us understanding, I'm just going to use this as a 6. So multiply everything on top here, meaning to say this whole equation that we see here is going to be multiplied by a 1. So nothing is going to change. In this case, minus 12r plus 8p will be equal to 32. Nothing is going to change. This one, we are going to multiply by 6. Each and every part here, we are going to multiply by 6. So that's 6 times 2r, which is 12r. So as you can see, these two are the same, 12 and minus 12. All right. Then we do the same on p. 6 multiplied to 3p in this case, which is going to give us positive 18p, is equal to, we have got 6 and -14, which is going to give us negative 84 in this case. So the question is, on these two equations, how are you going to solve for P? How are you going to solve for R? All right. Once these two are the same, you have to eliminate, you have to remove this part. That is by elimination method. You have to remove the part that is got R in this case. So how do we remove? You have to ask yourself, am I going to add these two terms or am I going to subtract? With your calculator, you can even try to do this. All right, so let me bring back the calculator. Here we can try our numbers to say here there's minus 12. So you try minus 12 plus this 12 here. What are you obtaining? That's a 0. If we were to subtract here minus 12 like this, if we were to subtract, we are going to obtain negative 24, which is not a 0. So we need something that is going to give us a 0. So meaning to say, in this case, we are not going to subtract, we are going to add. The moment we add these two equations, it means we are going to obtain a 0 like we saw here. Minus 12 plus a 12 gave us what? A 0. So that means we have eliminated R. What we have done here, we are going to do it on the same. So it's 8 plus 18. So we're going to add 8 plus 18, which in this case is going to be a 26. All right, so we are going to obtain 26p equal to, we do the same, we add. So we are going to add these two, 32. So this is 32 plus, so take note here, there's a plus, then we subtract 84. So that's minus 84 like this, which is going to give us negative what? Negative 52. So on this side, we are going to obtain negative 52. Finding the value of P, simply divide by 26 both sides, by 26 both sides. That's the value of P is going to be what? On your answer here, divide by what? By 26. That's we are going to obtain P as a negative 2. So that is how we play around with the elimination method. You eliminate one part to find the remaining part. After finding this part, which is finding the value of P, we can now even substitute that value into any of these two equations that we have. We can substitute here, we can substitute here into any of the equations that we have. So here I'm going to choose equation 2 in this case. So we are going to substitute P equal to minus 2. All right, P equal to minus 2 in any of the equations. All right, in any of the equations. So that means in this case, we are going to plug in the value of P, which is minus 2, in any of these two equations. So here I'm going to choose equation 2, which is 2R plus 3P is equal to minus 14. So I can substitute my P, which is 2R plus 3 times our P, being negative 2, is equal to minus 14. All right, so that is 2R. 3 times negative 2, which is going to be negative 6, is equal to negative 14 in this case. So what you're going to do is to transpose negative 6 to the other side so that it will be a positive in this case. All right, so in this case, if we are to have this as a positive, that means it is going to be negative 14. That's negative 14 plus 6, which will be negative 8 in this case. All right, so 2R will be equal to negative 8. So to find the value of R, we divide by 2 both sides. So negative 8 divided by 2, that will give us what? A negative 4. So meaning to say our R in this case is going to be a negative 4, found by dividing both sides by 2 in this case, since we are multiplying. So this will cancel and this will give us a negative 4. So that is the condition. And with these values that we have obtained here, it simply means if we are to substitute these values back into any of these equations, it must give us exactly the same thing that we have, or exactly the same part that we are having on our equation. So what I'm simply saying is that, all right, let us say we have our calculator here and we have got the value of P and R. Remember, our R in this case is negative what? 4. If we are to substitute R here, negative 4, that is negative 12 into the value of r here, which is -4, all right, plus 8p, which is plus 8, into the value of p, which is -2 in this case, like this. We must obtain this answer, which is 32, all right, which is the same thing on the other part, 2 into r, which is -4, like this, all right, plus 3p plus 3 into p, our p being -2. We must obtain exactly -14, which is on the other side. And this is what we have. So that is how we play around with this information. All right, so we have the values of p and the value of r in this case. Let us check the other part of our equation, which was 1.2. On 1.2, we are now asked to solve the following quadratic equation by using factorization method. Already you're told the method to use there by using factorization method. All right, so you're asked to solve this equation. 3 marks for that, using factorization method. All right, so let us see our equation that we are given. So we are given our equation on 1.2 as 4e squared plus 27e plus 45 in this case is equal to 0. All right, so by factorization, that means we are supposed to factorize this side here. Already this equation is in the format that we know of a quadratic equation, that the side here is supposed to be equal to 0, whereby we have ax squared plus bx plus c equal to 0. So here the format is already fine. What we simply need is to factorize our left-hand side, equating to 0 because it's an equation. Remember here, we do not have anything that is common, so we can multiply the first term to the last term. So you multiply the first term to the last term. All right, so that we can have the factors there. So let us have our calculator. If we multiply this, we are going to obtain 4 multiplied to 45, like this, which is going to give us 108. So we're going to obtain 180 in this case, which is 180 e to the exponent of 2. So the question is that you are going to ask yourself, what are the factors of this term? So you need factors of 180. Take note, the first thing, you work with factors. You need factors of what? 180 e squared. But these factors should add up. Should add up. All right, these factors should add up to 27e in this case. So take note, the first thing is there must be factors of 180. Not to say you just choose 2 numbers which add up to 27. You just say, oh, okay, if I choose 20 and 7, they add up to 27. Are they factors of 180? That is the first thing that you're supposed to work, not to start by adding the numbers to give you 27e. There must be factors first, then you think about adding them to give you 100 and what? To give you the 27e that we have in this case. All right, so in this case, you're going to try all your factors that gives you 180, but if you check between the numbers 12 and 15, these are factors of 180. If you multiply these 2 numbers, they give us 180. All right, so we have got 12 and 15 in this case. If we multiply 12 times 15, they give us 180. All right, if we add these 2 numbers, 12 here, 12 plus 15, we get what? 27, which is the one that we want here. All right, so in actual sense, how do you come about these factors? How do you come up with these factors? Remember, these are factors of 180. So simply express 180 as a product of its prime so that you see all the factors. Express 180 as a product of its prime factor, as a product of its prime factors. This is the major part that we had in our N1, whereby we're expressing a number as a product of its prime factors to find HCF. So 180 is a product of its prime factors, meaning to say we start the smaller number, which is 2. We divide 180 divided by 2, that is a 90. 90 divided by 2, which is a 45. 2 cannot be used this time because we've got 5 here, so we're going to try 3. 45 divided by 3 is the factor, we get 15. We try 3 again. 15 divided by 3, we get a 5. Then we can't use 3, we use 5. So 5 divided by 5, that's a 1. So these numbers that you see here, these are factors of what? These are factors that affect, these are the prime factors of this number that we have of 108. So meaning to say, if you multiply everything that we see here, if we multiply all these numbers here, we multiply them together up to the last one, we get 180. If we multiply these two numbers. So what you do is that you test them because you are to find these vectors. So it's a matter of testing your numbers. Okay, let me explain this with a calculator. What I'm saying is that if we are to multiply these numbers here, we've got 2, 2, 3, 3, and 5. So if we multiply 2 times 2 times 3 times 3 times this 5, as we can see, we get 180. So what it simply means is that you can play around your factors to say, if you check these two numbers here, because it's a trial and error. It's a trial and error. If you multiply these two numbers here, you get 4. And you remain with these three numbers. You multiply them together. 3 times 5 like this. We get 45. Meaning to say 4 and 45, they give us 180. These are factors of 184 times 45, which is 180. But if you add, are you going to get 27? That is the present 4 plus 45 like this. You are not obtaining 27, you're obtaining 49. Meaning to say we can't use these factors. You try again another part, all right? So this time you are going to take everything, all right? These ones, they failed. So we are going to take this time maybe somewhere up to here, up to this point, 2, 2, up to this point. You try them. You remain with these two here. So if you multiply 2 by 2 by 3, that is going to be a 12. 2 by 2 by 3, that's a 12. So meaning to say these two numbers, they give us 12. 3 by 5, that's 15. So meaning to say 12 and 15, they are factors of 180. If we multiply these two numbers, 12 and 15, they give us 180. But if I add 12 plus 15, am I going to obtain 27? 12 plus 15, I'm obtaining 27. So that's how you come up with these numbers. It's not just, I just looked at the number and say, okay, there's 12 and 27. It's a trial and error, meaning to say you have to try the factors until you get the exact one. That's how you play around with this question. All right. So we agreed that the factors that we are going to have here is 12 and what? And 15. But since we've got E in this case in our middle term, we are going to, but what we actually want is to substitute these two terms into this middle term. But we've got E, so we're going to substitute with 12 with an E, 15 with an E like this. So it is going to be plus 12E plus 15E plus 45, which is equal to 0. Remember, yes, we are doing the factorization part in this case. All that we do here is the factorization part, which is fine. But this factorization that we are covering, it's under an equation. So you must maintain the equation part is equal to. All right. Remember from your factorization, if you've got 4 terms like this, you simply divide them into 2 so that you factor what is common in this case for the first 2 terms. And what is common here, it's 4E, 4 and E here. So after having this, we divide 4 and 4 cancels. E squared divided by E, that's going to be E. 12 divided to 4 here, 12 and 4, that's 3. E and E will cancel. So that is going to give us a 3 in this case. So we are simply dividing here this now. E and E cancels. 12 divided by 4 on your calculator, that's a 3. All right, you do the same thing. You ask yourself, what is the highest common factor between these two terms that are remaining? We've got 15 and 45 in this case. So 15 there is the highest common factor. So we are going to factor out 15. We divide 15E divided to 15. That will be E. 45 divided to this 15. This one is going to give you a 3. All right, that's equal to 0. So having the common brackets, this bracket and this bracket being common, we can factor out that bracket of e plus 3. By factoring out this bracket, what are we remaining with? If we factor out this bracket here, we remain with the 4e. So we are going to have 4e. Here, if we factor out this bracket, we are going to remain with what? With plus 15. So this one is going to be in a bracket is equal to 0. So that's it. Remember from here, each of these brackets must be equal to 0. So it's either e plus 3 must be equal to 0 or 4e plus 15 must be equal to 0 from this part. So that means we can solve for e by transposing each part to the other side of the equation. So 3 to the other side is going to be a negative 3. We do the same 15 to this side, it is going to be a negative. Then we divide by 4 at the end. So e is going to be negative 15 over 4. So take note here, it was supposed to be 4e is equal to transpose this to the other side. It becomes a negative 15. Then you divide by 4, you divide by 4. That's obtaining the value of what? Of e. All right, so these were the two possible values of e that we're supposed to obtain. E being equal to minus 3 or equal to minus 15 over what? Minus 15 over 4. So what you can do now, as a proof, you are going to use the formula to prove. All right. So this is what you do under exam condition. They asked you to use factorization method, which is fine. You applied your factorization, but this is exam where you need to check your answers if they are correct. So you can check by what? By the formula. Check by using the formula. So that is what you're going to apply in this case. We are going to check this by using our quadratic formula in this case. Using our quadratic formula, we know that it states that x, which is in this case, we are solving for e. So instead of using x is equal to, we are going to say e is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. You are now checking your values if they are the same. Remember, this is our a, the coefficient of x squared, the coefficient of this is our b and c. So meaning to say here we are going to have minus our b, which is 27, plus or minus the square root of b squared, which is 27 squared, minus 4a, our a here, which is 4, and c, our c, which is 45, like this. All right, everything over 2 times a. So this is 2 times a, which is 2 times 4. So I'm not gonna work out all the stages that we're supposed to do. I'm just going to use the calculator to prove our answers, because here it's just a proof. You're just checking your answers under exam condition to see if they are fine. All right, so let us plug in our values on our calculator and see that is going to be, okay, we need a fraction here. So there is negative 27. All right, where's my fraction? Get the fraction first. All right, okay. So that's negative 27 plus, we are going to start with a plus in this case. So we are going to have plus the square root of 27 squared. So here for 27 squared minus 4 times 4 times 4 times 45, like this. Everything over 2 times 4. Okay, which gives us negative 3. So as you can see, the first value there was negative 3. We get back our calculator here. Just get your calculator, change this here, remove this plus here, and put a negative. That is going to be negative 15 over 4 in this case, which is the second solution that we obtained in this case, negative 15 over 4. So that's how you play around with this. Just check your values if they do correspond to this part. If they do correspond, then it means you have used your factorization properly. All right, so that was our question. Then we move on to 1.3, whereby we are now asked to make C the subject of the formula on 1.3. Okay, so this is our equation. So there we are asked to make C the subject of the formula, and that was 4 marks. All right, so we're going to take this aside, 1.4. Okay, so let us see what we that was 1.3. Okay, so there we are given that 7 that was 5 over 7, not 7. 5 over 7 c to the exponent of 3 is equal to omega. So the sign that we are given there is the omega. So that was the omega sign. This one is the omega. Remember, we talk about this in our industrial electronics or even in our radian concept. And if we're talking about the sector of a circle, we talk about radians there, omega being involved there. So this is omega. So they want us to make C the subject of the formula from this given equation. So making the subject, it depends with the way that you actually want to work with. It depends what you actually want to work with. So in this case, maybe I can say I have got fractions in this case. This is same as over 1. I've got a fraction. So I can think of clearing fractions in this case. I can think of clearing what? Of fractions, whereby how do I clear the fractions? I have to multiply each and every term by the LCM. That is, I have to multiply by the LCM, which is the lowest common multiple in this case. So between 7c cubed 1 and c to the exponent of 3, which one is the LCM? Not the highest common factor, but the LCM. That is going to be 7c cubed. The number that we can take there, 7c cubed, can also be found here. So that LCM, you multiply by it, because we're saying multiply by the LCM, but we're not just multiplying by the LCM, you're multiplying each term. Each term is supposed to be affected by our LCM. So meaning to say here, our LCM, as we said, it's 7c to the exponent of 3. We are going to multiply each term. 7c to the exponent of 3. This term, 7c to the exponent of 3 is same as over 1. Here, 7c to the exponent of 3, which is same as over 1 over 1. So the moment you do this, you can now apply your multiplication concept, whereby you can cancel the numerator to the denominator where it is common. So that means we are going to remain with the 5 is equal to, here we're just going to multiply direct. We are not canceling anything. So it's omega times 7c cubed, which is going to give us 7c cubed omega in this case. All right, so that was 7c cubed omega, or 7 omega c cubed. Any way that you want to have it, it was still fine in this case. All right, then on this part we can see that we've got c cubed and c cubed, so this can cancel. We remain with the negative t and 7. So if we multiply, we are going to obtain negative ct in this case. So as we can see, after clearing our fractions, we are just left with only one term that is carrying c. Remember, our question there is to make c the subject. And we are just left with one term that is containing c, that consists of a c. So what are we going to do? We can transpose everything that is not having c to the other side of the equation, meaning to say minus 7t can be transposed to the left-hand side and become a positive there. So this one is going to be 5 plus 7t, which is equal to 7c to the exponent of 3 omega in this case. Again, we ask ourselves, since we are left with one term, it's true we have left with one term, and this term consists of t, but it also have other part that is affecting this term. This one is a single term, but it has other components that is affecting, which is the 7 and this omega. So we are going to divide by them so that we remain with a term that consists of c, or just remain with the c only. So that means here we can divide by 7 omega, both sides by 7 omega. This one and this one cancels, this one and this one cancels. We remain with the c cubed. So that means the c cubed is equal to what we have on the left-hand side here, which we're just gonna interchange, does not affect in this case. All right, over 7 omega in this case. All right, remember, if A is equal to B, it means B is equal to A. So these two are the same. So I can even start with the C on the left-hand side. Okay, it's one and the same thing. So we want to remain with the c, and there we've got c to the exponent of 3. So how are we going to remove now the exponent of 3? The opposite of the exponent of 3 is the cube root of. So this one is going to be to the cube root also, so that this cancels. So C is going to be the cube root of this whole part that we see here. So our C is going to be equal to the cube root of 5 plus 7t, everything over 7 omega, everything affected by this cube root. So that is how you play around with these typical questions, of which on this stage, someone could have separated, which is fine. At this stage, could have separated this when you divide it by 7 omega here. It was, let me take it this way. It was 5 plus 7t is equal to 7c to the exponent of 3 omega like this. You could have divided each term because you want to remove this. So you divide by 7 omega here, you divide here by 7 omega, you divide here by 7 omega. It's still one and the same thing. Meaning to say at the end, we are remaining with the c cubed equal to 5 over 7 omega plus this one and this one can even cancel because here you can see that here there's a 7, here there's a 7. So you remain with the t over omega in this case. All right, then you introduce the cube root both sides, the cube root here, the cube root on this other side. Still, it was going to be one and the same thing. So at the end, you remain with your c being the cube root of this part, 7 over 5 over 7 omega plus t over omega. The one that is writing this and the one that is writing this, we are simply having the same thing. If you are given values of t, the value of t and the value of omega, and you substitute these values, that is where you are going to see that, all right, these two are the same because you are going to obtain the same answer from there. All right, so that was our question 1.3. Move on to 1.4. We are given this 1.4 there. A father of 5 boys intends to, all right, so let's just remove this part. We are given that there's a father of 5 boys here, and he tends to travel out of town for weekend. But before traveling, all right, before he travels, he gave his eldest son a sum of 2,755 rand to share with his brothers, such that the 5 amounts should form consecutive whole numbers. These 5 amounts, meaning to say they are different amounts. The other one is going to get maybe 20. The other one is going to get another one. But they are saying these 5 amounts which were being shared together to give us this total amount. Because remember, this is the total amount which was shared, 2,755. But being shared, they must form 5 amount. These 5 amounts, they must form consecutive whole numbers. What are consecutive numbers? If you're referring to consecutive whole numbers, we're just referring to following each other. Like if we start 1, 2, 3, these are consecutive whole numbers in that order. So in such a manner whereby we are working with whole numbers, remember whole numbers, those are 10, 11, 12. So let's say the other one is going to get 20. The other one will be 21. The other one will be 20. That's what I'm trying to say. Consecutively following each other like that. That is consecutive whole numbers. So here we've got 5 brothers in this case that we are dealing with. All right. We have got 5 brothers in this case. They are sharing a total of 2,755 rand. This is the money they are sharing. And there are 5 of them. So if they are to give us their amounts, if they are to give us consecutive whole numbers, what is the difference that we have seen between consecutive whole numbers? If we say 1, 2, 3, there's always a difference of 1 between each and every consecutive numbers, whole numbers. We are dealing with whole numbers, there's a difference of 1. So meaning to say, if the first share, if the first share in this case is, we choose to apply X, what is going to be the second share now? If our first share is X, remember they are forming consecutive numbers, meaning to say there's a difference of 1 throughout. So if there's a difference of 1, we are simply going to add to this one, 1 plus 1, that's 2, 2 plus 1, that's 3. We add 1, we get a 4. We add 1, we get a 5. This is how you separate consecutive numbers. So if our consecutive number, because we do not know what was the first share that was obtained, so we're just saying let that first share be x. So the second share, which is the consecutive, is going to be x plus 1, and so on and so on. The third one is going to be what? X plus, we add a 1 because we are saying they are consecutive. So if we have got x plus 1, we add a 1 again. That will be 1 plus 1, which is going to give us x plus 2. So here we are going to have x plus 2. Meaning to say the fourth share is going to be the same. We add a 1 here, 2 plus 1, which is going to be a 3. And the fifth share is going to be the same, x plus, we add a 1 here, which is going to be a 4. So this is how the amounts are supposed to be separated. This is how the amounts were supposed to be separated. These are consecutive whole numbers. There's a difference of 1, 1, 1, 1, 1 throughout. So with these consecutive numbers representing the share of the given children, in this case, of these 5 brothers, it simply means that if we were to calculate, because our question is to calculate each share, so we just need to know what is the value of x. Knowing the value of x, we know the one that got the first share of x, the one that got x plus 1. But how were we going to get this? We simply need the total of this and add it to what? And add it to, and equate it to this total. So that's what we simply need. So if we add these x's, how many x's are we going to have in this case? If we add all these x's, this is going to give us what? All right, we can just have our numbers here, 4 plus this one, which is 7. Okay, that was going to be a 10, something like a 10. All right, we add these x's together, we get, there are 5 of them. So it simply means we've got 5x plus what? 5x plus 10 from this expression. If we add the numbers, we add the x. So this 5x plus 10 is representing the total, or you just add x plus 1 plus x plus 2 plus x plus 3 plus x plus 4, like this. You form an equation is equal to 2755. But still it is the same thing. If you add these x's together, they are going to give us 5x. If you add these numbers, 1 plus 2 plus 3 plus 4, if you add these numbers, you are going to obtain this 10 that we got. So it simply means 5x plus 10 is equal to 2755. So to find x, simply transpose this to the other side, it becomes a negative. So 5x was going to give us 2745. Then we can divide by 5 in this case. So x was going to give us something like 549. All right. Representing the first share that we obtained in this case. So if the first share was 549 Rand in this case, if this was our first share, which is 549 Rand, what was going to be the second share? Because the question was, in this case, to calculate how much each son will receive. So each is going to receive according to this part that we talked about, to say, all right, so this is how each is going to obtain. Remember, the first one, it's x. The second one is x plus 1. So meaning to say the second one, we are simply going to add 549 plus 1, which is going to give us 550 Rand. The other one, as they are, we add 2 because our x is 549. 549 plus 2, which is going to give us 551. So that is how you're going to add 552 and so on, 500 and what? 553, because they are consecutive, they follow each other. They are whole numbers. From each, there's a difference of 1 from each. So these were the amounts that were being shared by the given brothers. So meaning to say, if we add these amounts, they must give us exactly the sum of what? 2,500 and what? 555 in this case. All right. So if we are to have this on our calculator here, we want to check if these amounts are going to add up to this value. We add 549 plus 550 plus 551 plus 552 plus 553, like this. It gives us exactly the 2,000 what? 755, which we're given there. So that is how we play around these word problem. So a word problem is something that you just have to analyze from the question that you're given. You are given a condition, analyze from there how it is being given. All right, so that was the question number one, first part of our question number one. 14 marks for that. All right, so it was just a matter of playing around and understanding your question in this case. Question 2, we've got 2.1. In this case, on 2.1, we are given the following algebraic expressions. So these are the expressions that we are given. From these algebraic expressions, 2.11, factorize each expression completely if the highest common factor of the two expressions is. All right, we are given the highest common factor. Actually, our factorization is just direct. Yes, we can apply methods that you can have, but this part does not even matter to us. If we just know our basic factorization, it does not even matter to us because we can factorize this direct and see if 2y is the highest common factor, if 2y minus 5. All right, let us see what I'm trying to say. The first number that we have, or the first expression there, we are going to have it as, so this was even 2.11 now. All right, so the first expression was given as 24y squared minus 44y, like this, minus 40. Remember our golden rule of factorization, always to factor out what is common. If there is something that is common in this case, we can check here between our numbers. 4 is common there. It's the highest common factor actually. So here we're supposed to test these numbers before. So you can factor out 4. What are we going to remain with? 24 divided by 4. That was going to give you 6y squared minus 44 divided by 4. This was going to give you minus 11y minus 40 divided by 4. This was going to give you negative 10. Then you can do your factorization. Remember what I talked about from that previous part where we are supposed to apply the longer way of factorization. Multiply the first term to the last term. So it's 6 times negative 10, which is negative 60y squared. So what you simply need is that you are focusing with the negative 60y squared. You need its factors. That is the major part. You need the factors of 60y squared. You need the factors of this. But these factors should add up to negative 11y. So I think I showed you guys how to play around to check these factors until you get the proper one. And if you know your multiplication, actually, it does not affect as much if you know your multiplication. So here our factors was going to be 4y and minus 15y. You have to try on your calculator until you get something that is going to give you negative 11 y if you add. So if you add these two, you get negative 11y. So these are the factors that we are going to substitute into the middle term in this case, which is minus 11y here. So you're going to have 6y squared in place of minus 11y. We substitute these two terms, which is 4y and minus 15. So that is going to be 4y minus 15y minus 10 like this. All right. Knowing that there are now 4 terms that we have here, so we are going to group them into 2. So by grouping, so that we can factor out what is common at the end. What are we going to have? 4. All right. So in this case, between these two, we can see that 2y is common. So we can factor between 6 and 4. That is 2. Here there's y. Here there's y. So we can factor out 2y in this case, right? So you have to factor the highest common factor actually. So that's 2y. We divide 6 and 2. That is 3. Y squared and y. So that is going to be a y. And here we are going to obtain a 2 there. 4 and 2, y and y cancels. Here take note there's a negative. Here there's a negative there. So you have to factor out the negative first, which is common. Then check between the numbers 15 and 10. 5 is common there. So you're going to factor out negative 5. Negative 15 and negative 5 is going to be positive 3, remaining with y here. Negative 10 divided to negative 5, it is going to be a positive 2 in this case. All right, so this is what we are going to have. And checking now, we can see that we have something that is common. And this is always the case. These two brackets should always be the same. So you factor out that common bracket, which is in this case is 3y plus 2. And on this part, you remain with what? With the 2y minus 5 in this case. As we can check, the 2y minus 5, if it is the highest common factor, it means we must have it on this part because we are told that the 2y minus 5 is the highest common factor. So if it is the highest common factor, we are supposed to have it here. We can see that 2y minus 5 is appearing on this term. All right, so that is another part. We factorize this part of 25 plus 5y minus 6 squared. All right, so we're going to do our factorization just like the previous part here. Now we are having this as 25 plus 5y minus 6y squared. So this is what you're given. So just we can just try to start by writing y squared just like this part here, starting with y being squared. All right, so we can take this. Okay, let me just try to do this so that we can have this. Start with negative 6y squared followed by 5y followed by 25. We are just rewriting. We haven't, it's not an equation whereby another term is going to change the sign. We are just rewriting our expression starting with y there. Then doing our factorization just like the previous part that we saw in this case, we said we can factor out in this case this negative so that the 6 becomes a positive. You are not dividing, you are not removing this negative. It's not an equation. An equation, if this was equal to 0 like this, that's where I can divide by -1 by -1 to make this positive. But this is an expression. We are not dealing with an equation. We do not have equal to 0. So you factor out the negative if you want this to be a positive. You don't divide by negative on an expression. You factor the negative out, just like what we did on 4. You don't divide by 4. You factor it out. So if we factor out this negative, what are we going to remain with in this case? We are going to remain with negative cancels. So this will be 6y squared as a positive. 5 divided to a negative, it is going to give us a negative 5y. 25 divided to a -1, it is going to be a -25 like this. Now we have this as a positive, the first term as a positive, which is not of worry. If you actually understand your factorization, you can even try not to do this, just work it direct, but for the sake of understanding, this is the best. All right, so remember, multiply the first term and last term. So if you multiply these two, you are going to obtain negative 150y squared. So remember the concept, you have to check for the factors of minus 150y squared, but these factors should add up to minus 5y in this case. So I got something like 10y and negative 15y. Explained how do you obtain this. So this is what you're going to do at the end. You substitute them into the middle term, so that will be 6y squared. In place of the middle term now, we substitute our terms, that is going to be plus 10y in this case and minus 15y in this case, minus 25 at the end. All right, grouping these factors into 2, our terms into 2, we can factor out what is common between these two terms, which is between 6y squared and 10y. 2 is common, y is also common. So factor out 2y, we are going to remain with the 3y plus a 5 in this case, this one and this one, that's a 5. Between these two terms, there's a negative, so factor out the negative. 5 is common, so -5. That's we are going to remain negative 15 and 5. That will be a positive 3y if we divide. Negative 25 and -5, that will be a positive 5 if we divide in this case. So having these two brackets being common, I said you just have to factor out that common bracket, all right? So you're going to have minus here. Minus is still there throughout. So we have got minus, take out the common bracket, which is 3y plus 5. What are we remaining if we take out this common bracket here? We remain with the 2y. Here we remain with minus 5. So as we can see also, 2y minus 5 is appearing on our term. That is to mean truly this is the highest common factor. As we can see, this bracket is appearing both sides, but to factorize, we're supposed to have exactly these brackets as it is. So this was the first part that we're supposed to get, and from this part here, we're supposed to have these two. All right, then the other question now, which was a continuation, there was to determine the LCM of the two expressions after you factorized now these. What was going to be the LCM? Remember, LCM now, it must be common. Already we have factorized everything in this case, so it's simply a continuation in this case. So our 2.12, the LCM, remember guys, I said you take every term that is common, starting from the terms that are outside of the brackets. We've got a negative, we've got a negative. Every term that is appearing should be taken. So we've got a negative here, we have got a 4 here, so that's -4. We've got a bracket of 2y minus 5, 2y minus 5. It's appearing once this side, it is appearing once this side. So you just take it once as it is. You do not repeat that bracket, all right? You move on to the bracket of 3y plus 5. It has appeared. I'm saying every bracket that is appearing should be taken. Every bracket on this should be taken. Also, we have a bracket of 3y plus 2. It must be taken also, 3y plus 2. So the LCM, it's a multiple. It consists of every term that you have on your answers. But the HCF is the common factor. You take what is common only. We can see that the 2y minus 5 is the one that is common on these two brackets. So that was our HCF. But for the LCM, for this question, you're supposed to take every bracket that is appearing, every term that is appearing should be part of your LCM. Since it is a multiple, it takes everything. All right, so that is how we could have played around with our question. Then if you move on to the question 2.2, in this case, this one I actually was wondering what were they trying to do in this case on this 2.2. I was actually, okay, let us see our question. This is y plus 3 over x squared minus 4x plus 4 plus 1 over xy minus 2y plus 3x minus 6. Let's see if this actually will make sense at the end. We are asked to simplify. All right, so that was 2.2 in this case, whereby we are given y plus 3, everything over x squared minus 4x plus 4 in this case. So this was being added to 1 over this part of xy minus 2y like this plus 3x minus 6. All right, so this is what we are being given here. This is what we see, and we are asked to simplify this part. What exactly are we to simplify? We are to add this part because we are given this with an addition. So meaning to say we are supposed to add these two. All right. Remember, on your addition, if you're dealing with algebraic expressions, the first thing that is, what is actually best for us is to do there is to factorize, to make sure our denominators are in a factorized state. All right, so having our denominators in a factorized state, we are going to see the first part this time is just something that we can play around direct here, because we have got the coefficient of x squared, this one, the coefficient of x squared being a 1 in this case. So meaning to say you can just have our two brackets here. All right, so we've got x and x. What are the factors of 4? Do you have factors of 4? But these factors should give -4. Take note here, we're just dealing with the constant because already we've got x and x here. So we work with the 4 factors of 4, which must give us -4. So we need factors of 4, factors of a +4. But these factors of +4 should give us -4 if we add them. All right, so we have got -2 and -2. If we multiply this, we get +4. If we add, we get -4. So these were the factors that we're supposed to have. Take note, 2 and 2. Truly they are factors of 4, but if we add, are we going to obtain minus 4? No, this one, if we add, we get a positive 4, not a minus 4. So that's why we can't use this part, because it does not, it's not adding up to minus 4, all right? We do the same thing on this other part. We are supposed also to simplify. So this is going to be 1 over, we do our factorization in this case. All right, so what was the special part about this factorization? What we're supposed to do here? We check, these are 4 terms and we've got something common, something, so we are going to apply by grouping. Remember, by grouping, you factor out what is common between the two, which is y in this case. We remain with x minus 2. All right, we divide here, y and y cancelled, remain with x minus 2. What is common between these two? That was a plus 3. So we factor out plus 3. We remain with the 3x divided by 3, that's x, minus 6 divided to 3, which is minus 2. So as you can see, the 2 brackets are common. So we can factor out the common bracket, which was going to be x minus 2 into y plus 3, like this. So this is what you're going to have at the end. So meaning to say this whole part was going to give us x minus 2 into y plus 3. All right, so the first part is fine. Let's see where the part now affects us at the end. Given a condition like this, if you are to add, remember what you need is to find LCM of everything and to maintain that LCM throughout. The LCM being of the denominator, so x minus 2 and x minus 2, we are going to take this part, which is common, x minus 2. But we also have the x minus 2 that is remaining, is supposed to be part of your LCM, because every term must be taken. So we took the first one that is common, then we've got the remaining one. Then we also have y plus 3. Remember what I said about the LCM. The LCM carries everything. Every part here should be part of your LCM. So meaning to say every bracket should be involved on our answer. So the concept is that we are going to divide back our LCM to the denominator in this case. So as you can see, the x minus 2 cancel, x minus 2 will cancel. We remain with y plus 3. So that we are going to multiply y plus 3 on top, and the y plus 3 that is remaining, this one after these two we have cancelled, we are remaining with the y plus 3. All right, plus we do the same thing here. As you can see, if we divide LCM to this denominator here, x minus 2 and y plus 3 will cancel. X minus 2 and y plus 3, meaning to say we remain with what? We remain with x minus 2. So it is going to be plus 1 times x minus 2. You do not cancel the denominator. You just, it's just like an imagination to say this is what is happening. You're imagining, but you do not cancel your denominator to say this is x minus 2, this is x minus 2, I cancel. No, you do not cancel. At this stage, what you're going to do is to expand your brackets, collect like terms, in this case, on the numerator. The denominator, you just have to maintain as it is. So if we are to expand our brackets, y and y here is going to give us y squared. Then that's y and 3, which is going to give us plus 3y. In this case, we are done. We move on to 3. So it's 3 and y this time, which is plus 3y, 3 and 3, which is going to be a plus 9. All right. 1 is going to multiply x, so that's plus x. 1 is going to multiply minus 2 in this case. All right. So 1 is multiplying minus 2, which is going to be a negative 2. The denominator, you are not going to affect anything. Just rewrite as it is. So we've got x minus 2 into x minus 2. So this one can be even written as x minus 2 squared, like this, into y plus 3. We are not expanding, we are just rewriting what it can be written as. All right. In this case, let us collect our like terms. We've got our like terms here. Do we have any like terms? We've got 3y and 3y. In this case, these two can be added together. So that will be y squared, 3y and 3y. That will be positive 6y, like this, plus what? 9 minus 2, which is going to be a 7. All right, so you're going to obtain a 7 in this case, plus 7 plus x, like this. All right, everything over what? Over x minus 2 squared. All right, so you're going to remain with the x minus 2 squared into y plus 3, like this. All right, if we are to check what we are left with in the numerator cannot be factorized in this case. Yes, here we can apply factorization. Since we've combined here, we can try to apply our factorization, whereby we've got y and 7. We have 7 factors of 7. That gives us a 6. We actually do not have two numbers that we can multiply to get a 7. If you multiply these two numbers but add them, they will give you a 6. It's impossible. So meaning to say there's nothing common left. We can't factorize further. We can't group into 2 so that we factor out, because there's only one x and y. So that is according to this question. We're supposed to end at this stage. There's nothing that we can do further. All right, so this is how these typical questions, sometimes they might be as hoping that our department did not make an error, because these guys sometimes they just do a slight mistake and it affects everything. But in this case, according to this calculation, this is where you're supposed to end. We can't factorize, we can't simplify further, we can't factorize further in this case. Solve each of the following algebraic equation. Remember, that was the concept 2.22. Now we are given this one to simplify. What is it that we can do on this part here? All right. So remembering that whenever we are dealing with a division, I always say introduce multiplication first before you forget, because yes, you are supposed to factorize this and that, but before that, introduce multiplication before you forget. The moment you introduce multiplication, inverting the second fraction, meaning to say the first fraction is going to remain as it is. That's 5x plus 6b. In this case, we've got 5x plus 6b, everything over x minus 7, multiplied to, the moment we multiply, we invert. So that means the x squared minus 49 is now on top. So we are going to have x squared minus 49, everything over the denominator now with that 25x squared minus 36b squared. All right. So with this part, we can see that, all right, yet there's nothing that we can do actually on this part here. There's nothing. Gonna have 5x plus 6b. All right, let me just have it aside here. All right, let me just have it here. So we are going to have our 5x plus 6b, everything over x minus 7 multiplied to. Now we can factorize this part. That's when we can factorize here. We've got a difference of 2 squares. Remember from our difference of 2 squares concept that if we can have a squared minus b squared is equal to a minus b into a plus b. So this is what we have here. X squared, 49 is same as 7 squared when written as a perfect square, and when written as a number to the exponent of 2, that's 7 squared. Or you simply ask yourself, what is the square root of 49? That's a 7. So one bracket is going to subtract x minus 7. Another bracket is going to add x plus 7. All right, that's the same condition that you're having here. 25, it's a perfect square. 36, a square, x squared and b squared. So this 25 can be 5 squared, x squared minus 36, which is same as what? 6 squared, b squared. Meaning to say, we are also talking of a perfect square if these are being raised to the power of 2, the 5x and the 6b. So that is the major part that we need there. So that is going to be 5x minus 6b into 5x plus 6b. That's the difference of 2 squares there. Once you have your multiplication and you factorize, you can now cancel. By doing this, you won't even forget this part. That's why I'm saying it's important to introduce multiplication first, right? 5x plus 6b, 5x plus 6b, x minus 7, x minus 7. So we are going to be left with x plus 7 on top. So on top, we are left with the x plus 7 over our denominator here, which is 5x minus what? Minus 6b. So that is what we were supposed to have at the end. Yeah, at the end, we're supposed to obtain something like this. So that was the question 2.22. All right, let us check the other part. As you can see, it's actually sometimes something that you just have to work with more question papers or more revision so that you actually understand these exam techniques. On a 2.3, we are now given factorize the following expression completely. All right, so let us see what we're supposed to have here. This was 2.3. So if we are to check on this part, they are actually playing with us here because this part here can be simplified. If you check on your calculator, this was an exact term. Okay, let me bring in the calculator so that you see here. If we are to simplify 45 over 81 like this, that is going to give us 5 over 9, which is something that can be simplified, which means this one is not actually in its simplest form. So you can actually simplify this, which is going to give us what? 5 over 9. All right, so that means here we're going to remain with the minus 5 over 9 in this case. All right, checking these two numbers, we can see that on top here there's 20, on top here there's 5. You focus with these numbers on top. All right, because this is same as 20. Why am I saying the numbers on top? This is same as 20 over 1. So if you factor out, you must check what is common there from these two terms. And what is common between these two numbers? It's 5. So we are going to factor out a 5 in this case. The moment we factor out a 5, remember what I said, you are considering these numbers on top. So you are going to divide 20 divided to 5, which is going to be 4x squared. The same thing, 5 divided by 5, you're going to obtain minus 1 over 9. Or if you don't understand this, you simply use your calculator as it is. That is, you're going to divide 5 over 9 in this case. Divided to what? Divided to 5. You're going to obtain 1 over 9, which is exactly one and the same part that we have here. So from this part, we can see that this is a difference of 2 squares. Because here, we are having 4x squared, which can be written as what? Which can be written as 2x squared, minus 1 over 9, which can be written as 1 over 3 to the exponent of 2. 1 over 3 to the power of 2, that's 1 over 9. So meaning to say we have our a and b. A squared minus b squared is equal to a minus b, a plus b. So that is, we can factor out, we can factorize this as having our a, which is a 2x minus our b, which is 1 over 3. The other bracket is going to add 2x plus 1 over 3 like that. All right. So that is the whole concept. That's the whole concept that you simply need. That's the whole concept that was there, that was hidden there. All we just needed was to apply your basic factorization first. Then you can see that, all right, there's a difference of 2 squares later on. Apply your difference of 2 squares as well. All right, the other part now, we are given to solve for t. It's a logarithm. We are given to solve for t, 3 marks. That is the logarithm of t. So this here, okay, let me try to have it on this side. So this is the logarithm of t, and they've got the cube root of t. Well, okay, base of 2. Let me just rewrite how it was supposed to be, like 3.1. All right, so this was going to be 3.11 at the end. Is that so? Just 3.1. We are given the logarithm of t over the cube root of t in this case. This was the cube root of t in base of 2, which is equal to 2 over 3. So that we are asked to solve for t in this case. All right, and they have 3 marks for that. Okay, how can we solve this logarithm? Laws of logarithms, definitely are supposed to apply with our, to work with our laws of logarithms. Remember, I always say that from our log form, the logarithm of a in base of b, if it is equal to c, this can be given or can be written in index form. We can write this in index form, whereby I say this a is going to be equal to b to the exponent of c. That is in the index form or in the exponential form. A is equal to b to the exponent of c from a log form. So this is what we have. This is this whole part here represents our a. So it means the whole part as it is t over the cube root of t in this case is going to be equal to what? B to the exponent of the base to the exponent of the answer, which is to the exponent of what? 2 over 3. So it's going to be 2 to the exponent of 2 over 3 like this. That is what we're supposed to have. Now we are back here whereby there is no need for us to use logarithms. Here we are now back to our exponents. We have got t here, we've got a t here, meaning to say we can play around with our exponents, whereby we know that to the exponent of a third means that's the cube root, that's the t to the exponent of a third. The cube root of this means t to the exponent of a third. So we have got t over t to the exponent of a third equal to 2 to the exponent of 2/3. Having the bases here which are the same, and we are dividing, this is same as t to the exponent of 1. And if we divide, remember that we are going to subtract the exponents. X to the exponent of a over x to the exponent of b gives us x to the exponent of minus ab in this case. So that means we are going to have this as x to the exponent. It's going to be t to the exponent of 1 minus a third. We are supposed to subtract 1 minus a third, which was going to give us 2/3 in this case. And that's 2 to the exponent of 2/3. Remember, we always refer, if you check, mostly we always say, if the bases are the same, if you've got an equation, x is equal, x to the exponent of a is equal to x to the exponent of b. If the bases are the same, equate the exponents, a is equal to b. What if the exponents are the same? What does it mean? Doesn't it mean the same thing to say that t and this must be equal? That is what it means. So therefore, t is equal to 2 because exponents are the same. Exponents are the same. T is equal to 2. Yes, you could have removed this exponent by applying this concept to say, here I can use t to the exponent of 2 over 3 is equal to 2 to the exponent of 2 over 3. How do I remove this 2 over 3 so that I remain with a t? I multiply by the inverse, which is 3 over 2, by the inverse 3 over 2. The inverse, remember, it's 1 over this number. The inverse of 2 over 3 from your calculator, the inverse of a number simply means 1 over that number like this, 1 divided by that number that we are saying, which is 2 over 3 like this. That's the inverse of 2 over 3, which is going to give us 3 over 2. So with this inverse, you multiply it to the exponents here. So this one and this one, as you can see, cancels, remain with t. This one and this one, the same cancels, you remain with 2. But there's no need because here the exponents are the same. So definitely the bases must be the same. If this is true for all the laws, it must be also true for this one. All right, 3.2 again, simplify there without using a calculator. So you're asked to simplify without using a calculator. So this part we can simply even apply our laws again without a calculator. 3.21. Let us have our log in this case, the one that we're given. 3.21, we are given the logarithm of 32 in base of 16 times the logarithm of 2 in base of 4 in this case. All right, they say do not use a calculator, but what you do is that you check your answer on your calculator to see if you are going to obtain the same thing. All right, on your calculator, you've got logarithm base of 16 in this case, which is the logarithm of 32, like this, times the logarithm of base, which is 2, the base is 4, sorry, but being the logarithm of 2 like this. On your answer, you are getting 5, on your calculator here, you are getting 5 over 8. So meaning to say whatever simplification that you are supposed to get from this whole part here, it must be equal to 5 over 8. It's just an advantage that you know the answer. So you are supposed to work until you see the answer that you are given there, until you get this answer. All right, so what is it that we are supposed to apply in this case? All right, the first thing that we need to understand is that if I am given the bases which are different like this. It's actually, let's not talk about the base first. Talk about the multiplication there. What does it mean is that I'm supposed to work this logarithm separately. I'm supposed to work this logarithm separately. I multiply the answers. I have to work this separately, work out this separately, because I can't multiply these logarithms direct. I do not have the law that is direct for me to multiply. So meaning to say here, working with this logarithm, we can try to make these two numbers to be the same. 32 and 16 can be written in base of what? This can be written in base of 2. So that's 35 is 2 to the exponent of 5. 16 is 2 to the exponent of 4. All right, multiplied. We work out this one separately. 2 is same as 2 to the exponent of 1. 4 is same as 2 to the exponent of 2. Why thinking of writing the number and the base to be the same? Because there is a law that we know about the logarithm of a in base of a is equal to 1. If this number and this number are the same, we get a 1. And we also have exponents. So how do we get rid of these two exponents? All right, it follows also that this same logarithm of a in base of a like this, when it is raised to the exponent of m to the exponent of n like this, it is going to be equal to, all right, this whole part is going to be equal to m. So you're going to drop this m like this, and this n, you divide them. So it is going to be m on top over n, the logarithm of a in base of a. But we said log a base of a is equal to 1. So it is going to give us m over n at the end. So take note, if these two are the same, if we are dealing with an exponent, because here we've got I'm referring to these bases because we are talking about the bases being the same. The concept is that we are going to have log a base a at the end, which is m over n, but you can do that for proper calculation, for proper stages, all right? So I said here, we are going to drop this one and also drop our exponent. So they do on top, this one on top, you multiply with it. This one in the base, you divide by it. So that's 5 over 4. The logarithm of what? The logarithm of 2 in base of 2, you remain with 2 and 2 in this case. We dropped our exponents. We do the same thing times. If you check here, there's a 1. So you're going to drop this 1 on top. So it is going to be 1 over, you drop this 2 to be divided by. So it is going to be 1 over 2, the logarithm of 2 in base of 2 like this. So that is how we're supposed to work, whereby log a base a is equal to 1. So I have got log 2 base 2, the number and the base are the same. The number and the base are the same, meaning to say we get a 1 in this case. So this was going to give us 5 over 4 multiplied to 1. Sorry, we are also multiplying here, multiplied to 1 over 2, multiplied to 1 log 2 base 2 again, which is what? Which is a 1. So from this part, 5 over 4 times 1 over 2. Multiply on your calculator, that was going to be 5 over 8. 5 times 1, 4 times 2, which is 8. That is, we are going to obtain 5 over 8. In fact, no calculators, remember, no calculators. So we just used our calculator, this part, to check how our answer was supposed to look like. But the rest, we are supposed to work applying the laws of logarithms, no calculators on that part. So if we check, that was the same scenario that we are needed on this part here. This is the same scenario that we worked up, or that we want on this part, 3.22 again. So I'm just going to have this 3.22 here, but it is actually applying the same scenario of this part that we have been talking about of logarithm of a in base of a, and this concept of having an exponent where you have to drop that exponent there. So let's see how were we supposed to apply this same scenario on 3.22. All right, which was given as the logarithm was a fraction there, 1 over 8 in base of 2 minus the logarithm of 1 over 32 in base of 2 minus the logarithm of 1 over 4. So we've got the logarithm of 1 over 4 in base of 2. So if we are to check already here, there is something that is common here, which is the base already. So we can apply our laws of logarithms that if you are subtracting, we are going to divide, which is fine. But also with avoiding that, we can just express these numbers to say 1 over 8. Where is this 1 over 8? Remember, that's same as 2 to the exponent of minus 3. 1 over 32, 2 to the exponent of minus 5. So we can try to also write in the same base so that we can achieve the same concept, or you apply the other laws. Here, there were so many ways to work out this part, right? So we say this was going to be log 2 to the exponent of minus 3 in base of 2. Then on this one, we've got minus the logarithm of 2 to the exponent of minus 5 in base of 2. Here we've got a minus the logarithm 1 over 4. That's 2 to the exponent of what? Minus 2 in base of 2. So now we can drop the exponent. So take note here, we are saying it's going to be m over n. Here there is a 1 here. There is a 1. So the moment we drop this one, it's going to be minus 3 over 1. So it does not affect in this case. So that is where you see, or mostly you are given m log n is equal to log m to the exponent of n. They are just referring to this part on top, the log m on top. That is, you are just going to multiply. We are not considering the base in this case, like there's an exponent. So these numbers, they're just going to multiply our logarithms from our laws of logarithms. If there is an exponent, just drop that exponent to multiply the logarithm. So that's negative 3 times log, which is going to be negative 3 logarithm of 2 in base of 2. Negative 5 and negative is going to be a positive 5. We remain with log 2 in base of 2. Negative 2 and a negative is going to be a positive 2. We have got the logarithm of 2 in base of 2 in this case, whereby I explained that the logarithm of a in base of a is 1. So wherever there's log 2 base 2, we are going to substitute with what? With the 1. That is what it means in this case. So it's minus 3. So it's going to be negative 3 times 1 plus 5 multiplied by 1 plus 2 multiplied by 1 in this case. The logarithms are already taken out, replaced by a 1 because there's a log of a number and a base being the same. So it's replaced by a 1. So that is, we are going to have minus 3 plus 5 plus 2 in this case. If you add here, that's 7. 7 minus 3, which is a 4. So this whole part was going to give us what? A 4 at the end. So like I said, logarithms can be proved on your calculators. You do not work logarithms out of, so you work it on your calculator and prove log 2. That is, we've got 1 over 8 in this case. All right. Minus, we move on to the other part, the logarithm of, okay, the base there. We have got 1 over 32. 1 over 32, we move on aside, we've got minus the logarithm, all right, sorry, this one with the base, the logarithm, we've got the base there, the number, which is 1 over 4 like this. So you can see that you're obtaining a 4, a 4. So the calculator is just there for proof. You are not allowed to apply the calculator on this stage. You're supposed to work without a calculator, but you can use it as a proof now to say if your answer is correct or not. All right, so we have another part now on same question, which is question number 3.3. Use the laws of exponents to simplify the following. That was 4 marks to apply our laws of exponents in this case. All right, so how are we supposed to have this? Let's see. This was given as 3.3. So this is 3.3, whereby we're given 5 to the exponent of n times 125 to the exponent of n plus 1. Everything over 5 to the exponent of 2. All right, 2n to the exponent of 2n. There was 2n there. All right, there is 2n. 25 to the exponent of 2n. 25, not 5, but 25 to the exponent of 2n like this. All right. how are we going to play around? How are we going to simplify this? Okay, what we can just save is to write in the simplest base or the simplest exponent that we have in this case, which is we can consider 5. So you can try to write this in terms of 5, this in terms of 5, all right? So meaning to say that we are going to have this first part remaining as it is 5 to the exponent of n multiplied to 125 in the base of 5. That's 5 to the exponent of 3, all right? So that's 5 to the exponent of 3, but there's an exponent there of n plus 1, right? We do the same thing, 25 in base of 5, that is 5 to the exponent of 2, but we have an exponent there, which is 2n. So remember that if there is an exponent, if you are working with an exponent and another exponent, you simply combine the exponents together, multiply the exponents together in this case. So that simply means here, we are going to have 5 to the exponent of n multiplied 5 to the exponent of 3 times n, which is 3n, 3 times 1, which is a positive 3. Everything over 5 to the exponent of 2n times 2n, which is going to be a 4n in this case. And knowing that from our exponents, we can have this concept. If you are multiplying the bases, which are the same, you are going to add the exponents a plus b. If you are dividing the bases, which are the same, you are going to subtract the exponents. So on top, if we check here on top, we are multiplying the bases, which are the same. So we are going to simply add these. So it's n plus, we add to the other exponent in this case, which is 3n plus 3. But the other part in the denominator is being divided, and when you are dividing, we subtract. So this is going to be minus 4n at the end. All right, so that means we can now simplify this to a single term. So we are going to obtain 5 to the exponent of what? Collecting like terms, we've got n, 1 plus 3, which is 4, minus 4. So the n here is going to cancel. We remain with a 3. So that's 5 to the exponent of 3. Remember, 125 is the one that gave us 5 to the exponent of 3. So also you must simplify further to say 5 to the exponent of 3 is what? It's 125. Even from our calculator, we can check and see if we are obtaining the same thing. But that was it. Just that was it. I think a little bit direct, from what we can see. All right, then question number 4, we are now given there is a plastic company in Johannesburg produces baskets using synthetic rubber. It starts by processing the synthetic rubber into a cylindrical bucket without a lid that is open at the top. All right, so this is what we have. It's a cylindrical lid that we have. It's open on top in this case. So this is where we have our cylinder that is open on top in this case, having the height and so on. All right, so this is our cylinder. So this cylinder that we see here, what happened with this cylinder? It is having a height of 80 centimeters and a base radius of what? 20. So here we are told that it's open on top. It's open on top. So if it is open, the question is calculate the total surface area of the cylindrical container if the surface, all right, remember the surface area was supposed to be given as 2 pi r squared plus 2 pi r h. But because it's open, meaning to say we are removing this circle from our area, this area of a circle was supposed to be pi r squared. We are removing one of this one. From this part, we are going to subtract pi r squared, which is representing the part that is open here on top. That's why we see 2 pi r squared minus pi r squared ending up with what? Pi r squared plus 2 pi r h, this one. So actually they gave us the formula there. We are not supposed to even work out and so, but in real sense, that is what we're supposed to actually have. So this one was just a matter of substitution here because we are already having everything on our on this part. We have everything in this case. We're just going to substitute. So our surface area was going to be equal to, so this is 4.11. So we've got pi r squared. So that's pi times r squared, the radius of 20. So that's 20 squared plus 2 pi rh. So it's going to be 2 pi r, which is 20 times the height, which is 80 in this case. All right. So if you were to simplify this, you are going to obtain 3,600 pi, 3,600 pi, which is in square centimeters, or you can have this as a decimal, which was going to be 11,309.734 in square centimeters if you apply this properly. But that was the condition there. I think we are together on this part. Now they are saying here it was actually drawn a bucket here, a basket. They are saying to convert the cylindrical container into a cylindrical basket, a special machine is used to cut off, take note, 900 square holes. So we are talking about here, this part here now being converted to here the way it was shown, the holes here, like the squares here. So they are squares that we are talking about, 900 of them. All right. So the question is that, let us understand our question here. I want us to understand the question. In order for us to convert this, we are supposed to produce 900 square holes from the surface area of the body of the container, while the base, so from the surface, that is the sides here, are the ones that have got 900 square holes, whilst at that moment the base of the container is excluded from cutting. So while the base of the container, meaning to say the base here is not being affected, that was the same base that we are having below on this other shape that was here, it was not going to be affected. The base is going to remain as it is. So the question is to calculate the total surface area of the basket if the dimensions of cut square holes are 2 centimeters each. Remember, surface area, we're talking about the whole part that is being covered. That is why where there was an open circle here, we had to subtract pi r squared because it was open. So if we have got 900 square holes, it means out of this total surface area, we are going to subtract those square holes because they have an area which was removed, because these are holes that we are talking about. So we remove their area. All right. So that is the idea of the question. So meaning to say, at the end, we were going to have our total surface area for this 4.12 as the one that we obtained before. Our area that we obtained before, it's going to depend. We are going to work this one or this one, which was 11,309.734 minus the area of the square holes that we are having, each of 2 centimeters. Remember, the area of a square is side squared, which is from side times side. But there are 900 of them having a side of 2 times 2 each. So meaning to say we are going to subtract 900 times side squared, which is 2 squared. Remember, the side is 2 centimeters of the square that we're being removed. So this is the one that we are going to remove. We are going to remove the 900 squares which are there, having each area of 2 squared, which is side times side. All right, so that was going to give us the total surface area, which was going to be this one. If you simplify, was going to be something like 3,600. So if we subtract, we are going to obtain 7709.734, which is in square centimeters. All right, so that was our area in square centimeters. We're just going to remove those holes that are there. Then calculate the volume of 4.11. All right, 4.11, they are referring to the normal cylinder that we had. Calculate the volume. This is 4.11, this one, the normal cylinder that we had. Remember, if the cylinder is open or if it is closed, that does not affect the volume of a cylinder. All right, so meaning to say, on this 4.13, we are going back to the normal volume of a cylinder given on your formula sheet as pi r squared h, which is base area times height. So your volume is going to be the base area, which is pi times the radius squared, as it is 20 squared times the height of 80 centimeters in this case. So like I said, whether it's open or it's closed, the volume is not affected. So this was going to give us 32,000 pi. All right, 32,000 pi in cubic centimeters. Or as a decimal, this was going to be 100,530,965 in cubic centimeters in this case. All right, so that was supposed to be the volume of the container. So that is how you can be given such type of a question. Then let us see another part of our question, what we are given here. Now they are saying calculate, all right, here I jumped here. Do you think that the volume on 4.14, do you think the volume of the container in question 4.11 should be the same as that of the basket in 4.12? All right, substantiate your the answer in this case. Or do you think that are we gonna have the same volume in this case of this container and this other container? Yes, these two, they are going to have the same volume. The volume is not affected by being open or being closed. Like I said, even if we remove these holes that we have, we are going to have the same volume because volume is the space occupied. All right, the space occupied inside, that is what represents what volume. But the area is not going to be the same, because once you open those holes, the surface area is affected on the space that you actually on the portion that you actually see on real sense, like what is surrounding the everything that affects the area. So the volume is not. All right, so because we are saying volume is the space occupied inside, so that is the idea there of reasoning with your answer. 4.2, are given an irregular shape is one horizontal straight line, one horizontal straight side divided into two equal parts of 2 meters. All right, so that is the distance between the points and the height of the ordinates. So take note, these are our ordinates in this case. So take note, there's a difference between a comma, like 1,3, this one, 1,3, and the one that is separating the semicolon, this one. This one is for separation. This one is for separation. This part here is for separation of your values. How are they separated? When you see this part here is for separating values. Then this one, it's a comma. So it's 1,3, 2,4, 2,5. All right, so take note of, about you, how you are given this. So the question here was, we are given that calculate the value of P if the area of the plate is 33,3 square meters. We are given the area. Remember, how do you calculate area from the ordinates like this? We understand that our area is taken from, so that's 4.2. Our area is taken from the first ordinate. So there we talk about, all right, sorry, the first ordinate. Also, you're given this on your formula sheet. That's why I'm not gonna write it in full. The first ordinate plus the last ordinate, in this case, everything over 2, plus the sum of the other ordinates, which is the remaining sum of the remaining, which is the other ordinates in this case. Whatever that you get here, you multiply by the distance between. All right, so the formula given on our formula sheet is also direct. So in this case, we want to calculate the value of P given an area. So it's just a matter of substitute, because this time they gave us the area here to say our area is what? 33,3 square meters. So we're going to substitute back our area into the formula as if we were calculating this area. 33,3. It was supposed to be equal to what in the normal sense? We are supposed to add the first and the last ordinate in this case, which is our first ordinate. According to this information, take note, we are starting from this one. This is the first ordinate, which is 1,3. And the last ordinate at the end there, which is 1,2. So you're supposed to add 1,3 and 1,2. This is the first and last ordinate, 1,3 and 1,2. So you're going to add them, 1,3 plus 1,2, everything over 2, plus those ones that are remaining. So the remaining ones now are these ones that we are going to have. So we've got 2, 4, 2, 5, 2, 4, p plus 1. So this is p plus 1. This one is 3, 1. And here we've got a p. So these are the ones that you're going to pause. Already 1, 2 is taken. So you're going to take all these ones that are in between here. All these ones that are in between. These are the ones that we are going to take from 2, 4 up to p. All right. So these are the ones that we are going to take. Every part that is inside, those are the remaining ordinates, which in this case we said there is 2, 4 there. There was also 2, 5. There was 2, 4 again. Then we had p plus 1. So we take it as it is. Then we're also having 3, 1 and a p. These were the ordinates that we have here. Take everything, then the difference equal parts of 2 meters. That is the distance between. So meaning to say these ordinates are separated by 2 meters, the distance between. So that's we have formulated an equation which we can use to calculate for what? This equation, we can use it to calculate for what? For p now. We want to use to calculate this for p. So just combine this part, we can just remain it as it is, 33, 3. This one, you just use your calculator here. 33, 3 is equal to add the first term and the last term, divide by 2. In this case, you are going to obtain something like 1.25. So this was going to give us 1.25. All right. If you add these terms inside 2, 4, 2, 5, 2, 4, you add it to 1, you add it to 3, 1, you are going to obtain something like 11, 4 in this case. Then we are remaining with the p. So this p plus this p is going to give us 2p. Remember, you're supposed to work with the common terms, like terms there. 2p in this case, multiplied to the 2 that is outside of the bracket. So it's either you're going to expand by the bracket, or you're simply going to divide by this by these 2 both sides here. If you divide by 2, that means it will cancel these 2 here. So why am I using 3? It's 2. So that means we've got 33, 3 divided by 2, which is going to be 16.65, equal to, we can collect like terms, this part and this part, combine them together. That was going to be 12.65 plus 2p. Then we can even transpose. So the solving part here is up to you. You just choose the way that you want, but the idea was on the substitution. Once you have substituted this from this stage here, guys, to be honest, everything is up to you how we are going to solve. So if you transpose this to the other side, this was going to give you a 4, which is equal to 2p. So divide by 2, that's our p. Was going to be equal to 2. So that was the value of p that we're supposed to have in this case. All right. That is 4 marks for that. Okay. Question number 5, we are now given a function. We are now back to our functions in this case, whereby we are given the function of f of x. All right, so this part you're actually supposed to, okay, let's say for f of x aside, so that we can quick talk about this f of x. So that's our question 5. Our f of x is given as negative 15. So that was given as negative 15, negative 8x, negative x squared, like this. This is our f of x. And from this part, we're asked to find the y-intercept. Remember, the y-intercept is on a condition where x is equal to 0. All right. So our y-intercept 5.11 is when x is equal to 0. That's when x is equal to 0, substitute 0, the y is going to remain as what? Negative 15. So that's 0 minus 15 in this case. All right. So it's a matter of substitution. Sorry for that. It's just a matter of substituting your values in this case. All right. So if we check here, we've got the x-intercepts of f. The x-intercepts, these are the values that you obtain if y is equal to 0. So if y now is equal to 0, it means this whole expression of f of x is going to be equal to 0. So that means we can solve the equation. All right, just take these sides, minus x squared. Avoid working with the negative. To this side, it becomes x squared minus 8. This side, it becomes a positive 8. minus 15 to this side, it becomes a positive 15, must be equal to 0. So just work with factors here, two brackets, equate to 0. We've got x and x. Factors of 15 that add up to 8, we've got 5 and 3. If you add this, we've got 5 and 3 in this case. So x was going to be, if it is 5 and 3, it was going to be minus 5, or x was going to be minus 3 transposed to the other side. All right. So these are the x-intercepts that you're going to have. So 5.12, the x-intercepts are at a condition that f x is minus 5 versus 0. And when x is minus 3 versus 0 in this case, remember x is 0 when y, x it's minus 3 when y was equal to 0 at that moment. All right. Then we move on to 5.13, the axis of symmetry of f. Okay, 1 mark for that. The axis of symmetry is where your graph is going to be divided into two equal parts, that axis of symmetry. So it's on a condition where we can find from the solutions. So you can take this from the solutions where x is simply the values of x at the solutions there, minus 5 plus minus 3 over 2, which is the average of these values. So our x there is going to give us a negative 4, all right? We are going to obtain a negative 4, or we can use the formula for the x, for the value of x at the axis of symmetry. We've got x being equal to minus b over 2a, whereby we are simply taking from x being equal to minus b. Remember, from this part here, this is our x squared. So this part of x is the one that carries b. So b there, it's minus 8. So it is going to be minus 8. So the minus for the formula, our b is carrying a negative. So that's minus 8 over 2 times a. The coefficient of x squared is our a, which is negative 1. So this was also going to give us a negative 4 from our calculator. All right. So that's how you work with the x of symmetry, the y-ordinate of the turning point. So the y-ordinate of the turning point, it's at a condition where we use the value of x at the axis of symmetry. Remember, if your graph is being drawn where we have the axis of symmetry, that's where we have the turning point. That's where we have the maximum value. So it simply means in order for us to have the value of y at the turning point or at the maximum value, we simply substitute the value of x that we got here, which is minus 4. So y is going to be, in place of x, we are going to substitute minus 4. So there is minus 8x there, minus 8 times minus 4, minus x squared, which is minus 4 squared. You substitute wherever there is what? Wherever there is an x, you are going to substitute with what? With the value that we are given in this case. That is the whole idea of this question. So, meaning to say that having this, we are going to obtain our value of y at the turning point, which is going to be a positive 1 in this case. Y there was going to give us a positive 1. That's the value of y at the turning point. Then the question now is, use the graph paper to draw the graph of this on the system of axis. Indicate all the intercepts with axis and the turning points, as well as the axis of symmetry with a broken line. So with the information that we got here, this is the information that we are going to use now on our graph to draw this graph that they're asking us. We're going to take this information and see. So starting with the turning point, the value of y, the y-intercept, the x-intercepts, and so forth. Remember, this part here, we are talking about the x-intercepts. Here, we're talking about y-intercept. All right. So we're going to be having something of this nature. All right. Sorry for that. I just wanna have this graph here a little bit so that we can see. Okay, sorry for that. So this is our graph here that we are having. All right, so yeah, it's gonna take me much time, guys, to have this because of our time. But let me try to have it here, but I'll try to explain in our separate class how do we actually play around with this, because it's gonna take us much time like I wasn't expecting. All right, so in actual sense, you're supposed to have something of this nature. All right, you're supposed to have something of this nature. Your x and your y-axis from 0. You state the scale that you're going to use. I don't know which one you're going to take. Maybe you use 1, 2, 3, and so on. All right, 1, 2, 3, then -1, -2, -3. Then on the y there, since we've got take note the y-intercept there is at -15. So in order for you to have -15, you can try even to use scale -5, minus, or you can even try to use -10, whatever scale that you want. So you can use -5, -10, -15, -20. Use this according to scale. This is just I want you to see how your sketch was going to be like 5, 10. All right, so you mark your points. The first point being 0, -15, the y-intercept. That's your y-intercept. The x-intercept, the x value at -5, another one at -2. Oh, so meaning to say we have to extend this one, -4, -5, -6. All right, so as we are focused at -5 and at -3 like this, and we have got the one that is important, the value of x at the axis of symmetry, and its corresponding value of y gives us the turning point, which is -4, which is the maximum value. So -4, according to your scale, is going to depend how you use your scale, but maybe -4, it will be somewhere here because this is 5. So -4 is going to be below the 5, right? So what you need was to simply join with a smooth curve. This is supposed to give you a smooth curve when joined properly from one point to another. You're supposed to obtain a smooth curve. But in this case here, guys, I'm not using the graph here, so I'm not gonna have the smooth curve, but you're supposed to have something like this being a curve. So that was supposed to be your graph. I just hope you are going to obtain the exact thing, but I think on the drawing or the issue of graphs, we talked about the issue of graphs, or we had in particular the issue of graphs, or we shall work with that one properly, working with your graph paper so that you actually see how it is taken from your graph paper. All right, it was the same thing here. Draw a function of hx, which is y, of hy, which is -x, and of g. Okay, so these are the two functions that we're supposed to draw in this case. All right, so in order for us to draw these two graphs, let us start with the graph of y is equal to -x. So I'm just going to have a sketch here because of our time here. Okay, so let me try also to have a sketch which is just a little bit proper, just a little bit. Let me have my ruler. I was actually supposed to have this graph, but because I was removing this information, now I can't see it. Okay, but anyways, this is just a sketch again. All right, we just want a sketch here. So you're having your x and y axis in this case, and you've got two lines that you're supposed to draw. The lines can be drawn from table of values, or you can just use by approximation, okay? Because we actually know the lines. The line of y is equal to -x. It passes through the origin center like this. That's the line of y is equal to -x. But if you do not know this, you just draw a table, okay? So that's y is equal to -x. You draw a table of values for the values of x corresponding to the values of y. Let's say we've got -1, -2, -3, -4. Here we've got 1, we've got 2, we've got 3, we've got 4. Here we've got -1, -2, -3. So it's just an approximation that you're going to make again. Here we've got +1. Oh, this is positive, positive, positive on top here. As it goes up, it will be positive. All right. So you choose the values of x, like you can just say, let my x be -2, let my x be 0, or let my x be 2, like this. Okay, so with these values, you're going to substitute them now in place of this equation. So it's minus, minus. So if you take a look, it's going to be minus, minus 2 like this, which will be a positive 2. If x is a 0, that will be a 0. If x is a 2 here, that will be minus 2 like this, which is going to be minus 2. So y becomes minus 2. So you mark the points that will correspond. Minus 2 versus minus 2 is a point that you're going to mark. 0 versus 0 is a point. Then you are going to also to mark 2 and minus 2. That is how you play around with those with such typical questions. All you can have is a table from there, but like I'm saying that the line of y is equal to minus x, it's a line that we are supposed to actually know in real sense. We are supposed to play around with this type of graph, type of line. If sometimes they can give us for y is equal to minus y is equal to plus x, which goes like this. This one is for y is equal to x. For y is equal to minus x is like this. All right. So that's how you simply play around with this one. So if you were to draw your graph here, you're going to have your graph maybe something like this. So these points might not be direct, obvious, because here I'm not using a graph the way that is supposed to be like. All right. So your line was supposed to be somewhere, something like this. All right. So these points corresponding to the points which are what? Corresponding to the points that are being marked in this case, like here, guys, these ones, mine, they are not directly to the graph. All right. But you are supposed to obtain something of this nature. Y is equal to minus x. Passing, if you check, it must pass 2 and minus 2 must correspond. Minus 2 and 2 must on the line. All right, so this is how it is supposed to be like on the line. To say 1 and positive 1 on the line direct like that. You do the same thing for this other one that you are given. That is it's x over minus 3 plus y over minus 3 is equal to 1. How do we sketch this one? You can also use table of values, or we can just use the y-intercept concept. We are given x over minus 3 plus y over minus 3 is equal to 1. Remember, if it is a straight line like this, we can simply say, we talk about x-intercept. X-intercept is at a condition where y is equal to 0. So if y is equal to 0, we are going to remain with x over minus 3 equal to 1. So you can find x, cross multiply, x is equal to minus 3, meaning to say our graph is going to pass at minus 3. We talk about the y-intercept where x is equal to 0. If x is equal to 0 this time, it means we are going to have 0, meaning to say this one is going to be a 0, this one. And we remain with what? Y over minus 3 equal to 1. So y is equal to minus 3. So these are the 2 points that you're going to mark. The x-intercept, which is at minus 3, and the y-intercept, which is at minus 3. But in this case, because of our graph not properly to scale, because this one is not properly to scale, if it was supposed to be properly to scale, our minus 3 was supposed to be like here. It was supposed to be like this. If it was properly to scale, because this one can actually give me the scale later on. So this, our minus 3 was supposed to be here. So this is where our line was supposed to be like, our lines, they were going to be like this, all right? Your lines, they're going to be like this. So if you check these 2 graphs that we've just drawn, they do not intersect. They do not intersect, meaning to say they do not have solutions in common. In this case, we are saying they do not have solutions in common. The graph that we drawn, this one was for what? Let's take them. This one was for h, which is y is equal to x. Then for g, so the first one here was the graph for h, and this one is for what? For g. These 2 graphs, they do not intersect. They're actually parallel to each other. If we are to check at the end, if let's say we cleared fractions, there's another part that we, okay, let's see, they're actually asking this question here. They are saying, read the values of x for which f of x is equal to gx from the graph in 5.1. So in this case, we do not have exact solution from this graph here. They do not intersect. So meaning to say our solutions, they can actually be taken from minus infinity. In this case, the values of x can be taken from minus infinity because they do not end. They do not even end. Up to where? Up to the positive infinity, because we are not even having any exact value. They are not exact. They do not intersect, so they'll be taken from negative infinity up to infinity. That's the reason they are asking here on 5.23. They are saying, okay, sorry, okay. Use the graph in 5.2. Okay, this one. Use the graph in question 5.21 to explain why there are no values of x. Why there are no values, but yet they asked you for the values of x. Now they are saying there are no values of x, for which f of x is equal to, okay, this one is actually just an error the way they are writing here. This is h, this is g, so they are supposed to say hx is equal to gx, hx is equal to gx. So you'd be surprised, how are they writing here? So from these graphs that we see, there are no solutions, because these two graphs that we see, they are parallel, they do not meet. Another thing that we can actually prove that these two lines are parallel is to work out from this equation that we see here. Remember, parallel lines have got same gradient. This one, it's the line for y is equal to minus x, meaning to say our gradient is -1. We take this one. We want to find it in the form of y is equal to, so it's going to remove the -3, multiply by -3, by -3, by -3. So this one will cancel. You remain with x. This one cancels, plus y is equal to -3. Make y the subject. Y is equal to x to this side. It becomes a negative like this. So as you can see, we've got a negative, we've got a negative, meaning say they are the same, -1, -1. If these two gradients are the same, it means the two lines are parallel. So that's why we are saying there are no values of what? There are no values of x. These two lines, they do not intersect at all. They do not intersect. In actual sense, we are saying they are parallel. So you can't obtain a point of intersection if the two lines are parallel. It's impossible. All right. Then we are given that a physicist at a beach here in Cape Town studied the movement of the ocean waves during the turbulent weather and discovered that it is described by the equation. So this is the equation of the turbulent flow, which is y is equal to 3 cos t. All right. Draw the graph of the ocean wave. Okay. Draw the graph of the ocean waves for 0 to 180 degrees. So how is this ocean wave going to be? This equation that we are given is simply a trigonometrical equation. So you are simply asked to draw the graph of course. That is what they are saying. Just draw the graph of course from 0 to 180. So knowing that the graph of course, we can have it from the values of t in this case representing s to have the value of y. Remember I said the graph of course is separated by 90 degrees. So that's 0 degrees plus 90 plus 90, which gives us 180. So on your calculator, you're just substituting, making sure that your calculator is supposed to be in degrees. So it's just a matter of substituting on your calculator. So this one was direct here. So let us have our calculator here. Just put in your values, 3 cos. All right, my calculator here, there's R there to show that it's in radians. So I have to change this to degrees in this case of mine, because I was using this another way. So this is equal to 3 like this. It's now showing a D there. So this is 3 cos, our T being 0 there, our T being 0, our first answer is going to be what? 3. So we're going to obtain a 3. Then we move on to 90. It's like that, 3 cos 90, which is a 0 there. We move on to 180. So it's going to be 3 cos 180 and so on and so on. So as we are supposed to end at what? At 180, from 0 to 180. So knowing how the graph of cosine is taken as, remember how the graph of cosine is taken as, but you're supposed to have this on a graph paper, but here because of our time, guys, I'm not gonna have this. I'm just going to have a sketch of how you are supposed to have this as your final answer. So in the sketch of our graph of cosine, remember, we are taking our values from 0 to 180. So this is no longer x, this is now t. All right, from 0, we've got 90, we've got 180 degrees. and we've got 1, 2, 3, -1, -2, -3. So you mark your points 0 versus 3. This point is 0 degrees versus 3, which is here, 90 versus 0, 180 versus -3. It's not a straight line. Remember, the graph, of course, is supposed to be like this. So you draw it in the same way. The graph, of course, is supposed to be like, it's not like you are having a straight line in this case. This is not a straight line. This is supposed to be like this, showing that we are going to have a curve there at the end. All right, but taken from where? From this point up to this point. All right, so that was our question. Then they are asking now, on the other hand, determine the height of water up, the height of the wave above the water level, above the water level. This is our water level here. So the wave is going like this is our water level here. So the wave is going up, down, up, like that. So above the water level, the height there is what? Is 3 meters. So that is the height that you're going to have, which is of what? Of 3 meters above the water level. That was the idea of our question in this case. All right, so I actually had this part of the graph. All right, what happened with my other graph? I wanted to actually have this other graph drawn, but I don't know, my information just erased, like, I don't know. So I'll see this part of the graphs on another part, because I actually wanted us to have this part of graphs, but now, as we can see, my information just erased. So we'll see it later on. So on question number 6, we are now given a learner read the angle, all right, of a triangle of 7 degrees, 54 minutes. So this is the angle, 7 degrees, 54 minutes. Write this number and convert it to degrees only. So this is the number. We have written our number, and they are saying convert it to degrees only. So to degrees, we have to change the minutes to degrees. Remember, a full degree is equal to 60 minutes. So you just have to change this to degrees, divide by what? By 60. So you're going to have 7 degrees, 54 over 60. So 54 over 60 in degrees. So that's 7 degrees plus 54 over 60 as a decimal is going to give you 0.9 degrees, which will be 7.9 degrees. All right, so just use this conversion. If 1 degree is 60 minutes, what about 54 minutes? It's how many degrees? So it's a simple proportion that you're playing with them. All right, so let us check the other part of our question, which is 6.2. Consider the diagram. So we're given a diagram to consider in this case. So this is a horizontal. We're given the point C as XY. So meaning to say, if we are given this as XY, it means going this side, it's X. Going this side, it's minus Y. It's minus Y. Going this direction down, it's minus Y. Remember, this is X-axis, Y-axis. And we are given OC, from O to C, it's 1. Okay, copy and complete the following table. So this is the table that we have, and we are asked to copy it and complete it. So this one was just a mere application of the ratios. Remember, we've got theta from our soccer tour. From our soccer tour concept, we've got the ratio of sine theta being the opposite over the hypotenuse in this case, the ratio of sine being opposite over the hypotenuse. This is what you simply need, sine theta. According to this theta, our opposite here, this is according to theta. This is our opposite side. This is our adjacent, and this is our hypotenuse. So sine is opposite over hypotenuse. That's our opposite there, which is, in this case, it's minus y over hypotenuse, which is 1. So this one was going to give us minus y over 1. Cos, it's adjacent over hypotenuse, adjacent, which is x over hypotenuse. So it's x over 1. Okay, tan, which is opposite over adjacent. So according to tan, we've got opposite here over adjacent. So that's minus y over x, opposite over that. That's how we answer this part. Then cot, remember cot of theta, it's 1 over tan of theta, which simply means the opposite of what we have, which is now adjacent over hypotenuse, or just 1 over. So if we say adjacent over the hypotenuse, in the adjacent over the opposite, in this case, adjacent over the opposite, it is going to be x over minus y, which is simply the inverse of this. Sec, we know that sec of theta is 1 over cos of theta, and 1 over cos simply means it's the opposite of this. So 1 over cos is just opposite, invert what you have, which is 1 over x. The same with cosec, 1 over sine, invert what you have. So you're going to have 1 over minus y in this case, or minus 1 over y. That's how you play with these ratios. They are just direct to the point. In this triangle, ABC, we are given that angle C is 20 degrees, and this one is 190, just 190 units. We don't know centimeters or what. All right. Calculate 6.31, the value of B, angle B in this case. All right, we know that angles in a triangle, they add up to 180 degrees. So we're going to subtract these two angles. Remember, this is 90 degrees. So we're going to subtract 90 degrees and 20 degrees from 180 to obtain our angle B. So that was going to give us 110 here. We subtract, that will be 70 degrees, or simply, we know that it's a triangle. So if we remove 90, these two angles must add up 90. So you can subtract from what? From 90, or just leave it like that. All right, then the other part, the length of AB. So this is the magnitude of AB. You see this line is the magnitude, which is the length. So the magnitude means the length. So they want us to calculate the length of what? The length of AB, which is this one. So according to this angle, we can play around according to this 20 degrees. This is one that I'm using. This is my opposite. This is my hypotenuse. So which ratio can I use? Which uses opposite and hypotenuse? That is the ratio for sine, as we saw here from our soccer tour concept, sine, opposite over hypotenuse. So meaning to say, we are going to have the sine of what? The sine of theta, which is 20 degrees, is equal to the opposite, which is the length that we have to calculate, which is AB. So it's AB over the hypotenuse, which is 190. Cross multiply here, 1 times AB. AB is equal to 190 cos what? 190 sine 20 degrees. So that means our AB is equal to what? 190 sine 20 is going to be 64,984 units. So we can't say meters, we can't say centimeters, because this one is not given the units, so you can just write it like that. That is the magnitude of this line. AC, so on AC, you can also do the same thing according to this angle that we are talking about of that. This is the adjacent. So you need a ratio that has got the adjacent and the hypotenuse, this one at the same time. So I'm referring to this angle, not to this one that we calculated here. I'm referring to this angle of 20. So that means we could have calculated this, or you could have even used Pythagoras theorem, because we now have two sides. Okay, so this was going to be cos of 20 degrees is equal to the adjacent, which is AC, over the hypotenuse, which is 190. Again, cross multiply here. That's AC is equal to 190 cos 20 degrees. Okay, so that's 190 cos 20 degrees here. Okay, so that was going to be cos 20 degrees. So our AC at the end was going to give us 178,542. All right, so that was the idea of this question. 2 marks. As you can see, the trick part there was just direct. It was just direct. All right, 6.41. We are now given, calculate the area. Okay, we're not to calculate the area, but we are given that considering a sector, the area of a sector is 8,7 square centimeters in this case, and its radius being 1,2 centimeters. Calculate the angle in radians. All right, this was another question which was actually not making sense to me, because if we are given, let us see what's going to happen at the end, but still is fine. This is our sector here, having angle theta and a radius. Remember that if you are given area of a sector, our formula states that this area was obtained from half r squared theta, where theta automatically, if this is used, our theta is in radians. This is used when theta is in radians. So they want us to calculate the angle theta in radians. So it was just a direct substitution that you're going to simply make in this case, where you are given the area, our area of 8,7. So 8,7 square centimeters in this case is equal to half r squared, our radius squared, which is 1,2. So it was going to be half of 1,2 squared times theta. So this is how you just had to play around, divide by the whole of this part here on this other side, or you can simplify stage by stage. This was going to be 8,7 is equal to half of this was going to give us 0,72 theta. So to find theta, divide by 0,72 by 0,72. That's our theta is going to be equal to 12.083 in radians in this case. All right. Then they want us to convert this angle to degrees and minutes, the same angle that we are talking about, which is the angle of a sector, which is given as 12 rad. So to degrees and minutes, which concept are we going to take? The first thing is that we have to convert first to degrees. All right, we have to convert this to degrees. So it will be 6.42. So you know that in degrees, pi radians is equal to 180 degrees. So as we have got 12,083 radians. So what are you going to obtain in degrees? So you can simply use our calculator. That will be 12 over, all right, 12 comma. So you're going to have a fraction, this one on top. So it was going to be 12.083. So that's 12.083 over what? Over pi. So this is over pi here times 180 degrees like this. All right, so this was going to give us 692, some which is actually above what we are expecting. 692 degrees. Okay, 692,30 something like that degrees, of which this is above the 300. So according to this question, because of the marks there, I don't think you're supposed to change. Just leave it like that, because in order for you to change to obtain an angle that is into the region with the 2 marks there, it does not even make sense at all. But these guys, they can actually do it. I don't trust these guys. Anyways, so this is a complete angle of 692. 692 degrees is a complete angle. So you remain with the decimal. So you subtract 692, our complete angle, in this case, this one, so that you remain with the decimal, the one that you're converting to minutes in this case, because remember it's degrees and minutes, and I explained before that 1 minute is equal to 1 degree is equal to 60 minutes. So we are going to simply multiply the remaining answer, the decimal part, by 60, which is going to be 18.29, which is 18. So meaning to say we are going to remain with the 18 minutes in this case. But this 692 is same as, you can even subtract 692 minus 360, a complete revolution, which is 333 in this case, 332. So as below 360, it's going to be 332 degrees 18 minutes, which is the same as 692 degrees 18 minutes. All right, so that is how we could have worked out this one. And on the other hand, we are now given the diameter of a circle is 4 times the length of the chord. Remember from we have this part here on our formula sheet, which describes about the length, the diameter, the height of a chord in this case. Let me just show you so that I do not confuse you guys. We have this part. So I want you to just check. I'm just gonna have it direct here. We check given segments of circles, chord length represented by x, the height of segment h, the diameter d, and this is the formula that you're going to use. D squared is equal to x squared plus 4h. All right, so from this information, they gave us a certain information that the diameter is going to be 4 times in this case. That is what we have on this part here. Given that the diameter of the circle is 4 times the length of the chord, we saw that the length of the chord is given by x. So meaning to say our diameter is equal to 4x, 4 times. All right. So of the same circle in this case, calculate the length of the chord, which is x. So the question is for us to calculate x of the chord if the height of the segment is, we are given the height of the segment, which is square root of 15. So this was just a substitution that we are supposed to make into the formula, whereby we are saying d is equal to h plus x squared in this case. Okay, over 4h. So we're going to make a substitution whereby d is 4x. So 4x is equal to h, which is a square root of 15, plus x squared is just going to remain as it is, which is x squared over 4h, which is 4 square root of 15, like this. So you're supposed to solve for x. As you can see, you're formulating a quadratic equation since the highest exponent there is what? Is 2. But what can we do? Can clear the fractions, multiply by 4 square root of 15 here, multiply by 4 square root of 15 to clear our fractions, 4 square root of 15. So this can cancel here, you remain with the x squared. So that means we are going to have, if you multiply here on your calculator, this was going to give us 60. All right, if you multiply properly here, you're going to obtain 60 plus x squared. On this side, if you multiply this properly, you are going to obtain 16 square root of what? Of 15 times x. Since this is a quadratic equation, we can just start by writing, take this to this side so that we can have our equation having x squared starting with a positive, all right? So this will be a negative 16 square root of 15x, 60 to this side, which is just gonna remain as 60 where it is. This is equal to 0. So since I'm to solve this, it's a quadratic equation, and as you can see, our values, they are going to be affected here because on our calculator, if we check, we are going to have this as this part of negative 16. It's negative 16, the square root of 15 like this as a decimal, which is going to be negative 61,968 like that. So it's going to be negative 61,968x plus 60, which is equal to 0. So from this part, we are going to use your quadratic formula. Since there's a decimal here, you can see that it's not, we can't use this direct our factorization. So we have to use our quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. So x is equal to minus b, which is minus 61,968 in this case. So there's a negative here, so it's minus minus, plus or minus the square root of b squared, which is minus 61,968 squared minus 4ac, our a there, the coefficient of x squared, which is 1, times our c. This was supposed to be the proper evaluation that you're supposed to make, 2 times a. So obtaining the two possible values of x, starting with the plus on your calculator, you go to the minus on your calculator. The first one was going to give you 60,984, or the other x there was going to give us 0,984. So you're actually obtaining two possible values for this. So guys, that is how it was supposed to look like. That is how it was supposed to be like. And as you can see, yeah, that's it. Total of 100. Just need to work with more questions, more revisions, but also thumbs up, guys. Let us try also to share our videos to our friends and colleagues so that they also learn from this platform at Mason African Motives. And also don't forget, if you haven't subscribed yet, make sure that you subscribe. But the major thing, let us continue to share our platform to as many people as we can. But for now, that's it. Till we meet again.